All right, and can somebody check the YouTube if you can watch the screen and the voice?
Oh, how can we see it?
If you go to the meetup.com, there is a link or the Facebook.
Oh, the Facebook.
Check. Or just go to the meetup.com.
Okay.
And there is a link in the comment of today's event.
You good?
All right, that's cool. All right.
This will be good because you can hear it coming back through again.
Yeah, right. Yeah, that's cool. All right, so the Wi-Fi code in front and the picture side, and there's the free drink outside, the restroom outside, and the show will begin in how many minutes? 4-5 minutes. And please introduce each other, make a friend. It's networking time now.
You stopped the call yet?
Sorry?
You stopped the call yet?
I already started. I already sent you the invite.
Yeah, send me the invite, but all it does is send me to the chat room.
All right. But there is a video button, right? In the chat invite.
Yeah. I got it now.
All right. UI isn't great.
Error, you're not allowed to join this video.
No? How come?
No, I can.
And Savita, could you write down the company name?
Yeah, currently I'm not working.
So free. Okay.
Yeah.
I write it down as a free. And yeah, Alex, sure. Could you write down your name and company name?
Oh, yes. I feel like I did this more planning.
Is it in the
No. Okay.
Mm-hmm.
What happened to the face?
He can't use it anymore because he can't afford his own.
That would be Cosmos Daily. And I tried to recreate by using the IoT Edge kind of stuff.
What? I see. That's too bad.
Maybe I'll stop using private mode.
That looks slightly different, and I don't see you.
That's still a new one. Yeah, I did accept. They use non-private mode. I don't want to log in with my email on this house log out. So I can keep my email. I'm the one.
Italian 2 months.
Oh, I see. So you haven't.
Well, it's in the process.
It is in board.
Because my company also uses Google.
All right. It's board.com, the gmail.com.
Teams.board.com. But not for email. So we can't get email through here. We just use other Google services. Like Google Drive.
IoT, blockchain.
I invite you. Let me invite again. Board.
Yeah. No, it should work now if I stop using the private mode.
All right. I sent another invite.
We're focusing on agricultural data. Long and short of it is we're basically getting a position. So we're building up a system to handle that. Well, officially I haven't changed. Unofficially I've been working for the past year.
No, simply going to the hangouts.google.com.
There's a bit of confusion because they started as a charity.
That's the easiest way.
Because they're focusing on blockchain, open forecasts.
I see what's going on.
Done that with the And you can make money, but you need a large number of people.
Did you see the issue?
And before you get there, you have to invest a lot
I'm
of
on
money.
that's the correct.
For a startup, that's kind of hard to get. So there is some jobs on the side, and one of them is something like realistic. I get to work on IoT data. I build a scalable system.
All right, problem. How does someone help you?
Well, we're not even trying to generate data.
Right.
All right.
A couple hundred devices out in the world. There's like thousands of devices.
There, now it's correct.
But only a couple hundred actually use. And we've passed 2.2 million rows of data.
Now I don't know what I'm using.
By the end of the year, we'll probably have 100.
And you're on mute, right?
Yes.
And can I just pass? Not yet. Not yet.
All right, so we shall begin. And could you grab one more pizza because we don't want to waste pizza. And are you already have the drinks? Yeah. Good. Cool. All right.
And then we might actually go.
I think pizza.
Mini pizza. Pizza.
I think maybe it's a basic one.
Yeah. Yeah. Cheese and cheese and the
People that are really SQL and adopted it, or possibly SQL too quickly, and then people put it in the vice versa. And I got it back end. It depends on the nature of your problems.
All right, let's start.
What you need
All right, so thank you for coming to the .NET, Tokyo.NET Developer Meetup, the number 44, I guess, 2019 April. And thanks again for the Nedo to sponsoring the pizza. We have a large two-size pizza for this amount of people. How many people are in this room? Hundreds?
That's a gigantic pizza, it's the size of a table.
Yeah, it's a pizza campaign.
To get one free.
So it looks like Nedo will give us two pizzas. Actually, it's just pick one, right? And then they just finished the great event called the DevOps Tokyo, or Tokyo DevOps. DevOps Days Tokyo.
Yeah.
The reason why I do not remember the name correctly is not I'm not invited. That's why. So next year I'm expected to be invited. And today we have two speakers, Jim and me. Jim is talking about something F word.
Yeah.
Yeah. And which is a .NET Core Web API, or how you integrate.
Well,
Let's see. So here we talk about the great security, the technique with .NET application. And after I will talk about the Azure IoT Edge. I hope you guys enjoy. All right, so let's start. And let me give you the control.
So I pause my side.
All right, now it is unmuted and I will start to share my screen. And we'll get that, as usual. Hello everybody. Oh. So you are witnessing history this day because this is a day that I've actually prepared some slides. I don't normally go through the trouble of making slides, but I was very enthused about this topic and I thought that it deserved some diagrams and explanation. Right. I even made animations. Look at that. Beautiful. So here's my self-introduction. My name is Jim Borden and I work for Couchbase. I live in Tokyo where I have resided, well, for the past, let's say, 7 years, and I've been in Japan for 9. Languages I use are English, Japanese, C++, C, C#, and PowerShell. I am the senior software engineer, and you can find me on the internet in most places, BORRDEN. The only place where it's different is Twitch, where for some miracle, somebody for the first time in 20 years has taken this handle before me. They are in trouble. So here's a quick overview of what I'm going to go over in the slides. And a kind of like primer for the things that you need to understand. So what I'm talking about is FIDO. It stands for Fast Identity Online. And this is the second iteration of it. The first iteration was sort of a mismatch of different things, and they actually wanted to get things together and make things standardized this time. It's a new web standard for passwordless authentication, and it is supported by all the major browsers today. It's been supported for a few months, or maybe even like 6 months now. And well, I work at Couchbase. I'm going to be showing some Couchbase tools today. So just something you need to understand about the Couchbase stack is that it's device to cloud complete data stack for storing and syncing JSON-like data. So we call a document database. And we have a library on the mobile device that you can use in an application. There's a Edge cloud component called Sync Gateway, which syncs data between devices. And there's the backend cloud layer called Couchbase Server, which stores the data and make sure it doesn't get lost. And if you combine these two together, you can create a method for passwordless user creation and authentication for data security. So there's kind of two ways that, in general, you can use FIDO2. There's the desktop FIDO2 that interacts with an external hardware authenticator. I have mine here. It's about the size of a very thin USB drive, and it has a button, a contact button, like the one you see on the front of a PlayStation 4. You don't actually push it, you just sort of make contact with it to make it pushed. And on YouTube, I'm gonna switch my camera on a little bit second later so everyone else on YouTube can see what I'm talking about, but this is the actual thing that's doing the authentication. And you can buy, this particular one is a YubiKey 5, costs about $50. And it can do more than just what I'm doing with it today. There's also UV security key, which costs $25, which does only this. And as I showed, this one is USB, but the approved transports in the FIDO standard are USB, near-infrared communication, and Bluetooth low energy. So these, if you have a form of communication with these, so say I have one on my phone, I can communicate via Bluetooth if I so desire. Then there's mobile FIDO2, which is more of a, catch-all experience. It uses an onboard piece of hardware as an authenticator. For example, the fingerprint sensor you see on most phones these days. And Android, the Android OS was FIDO certified as of February 2019. And its fingerprint sensor has, in addition to Windows Hello fingerprint sensor, can act as this sort of authenticator. And I'll get into what the authenticator actually does in a bit, but think of it as a replacement for those 6-digit numbers that you always have to copy over when you do two-factor auth. Here's a diagram that I stole from the internet. Actually, the FIDO2 Alliance webpage, I took it from there. So kind of how it works. You've got up here, there's my stuff, pointer. This is the application in the cloud that's going to be doing the authentication. I'll call it the FIDO server. And this is the browser, obviously. It's going to be talking to this. And then it also has some JavaScript APIs for platform. And the platform will be doing one of two things. If it's on desktop, as I said, you can go to the external authenticator, and it uses something called CTAP, or Client to Authenticator Protocol, to communicate back and forth. I guess there's another word called FIDO server over here, but I've simplified these two things into one thing for today's demo. But in reality, you probably do something more complex. But it's doing the actual authentication request, the challenge, we say. And then it's either going out to the external authenticator and coming back signed, or using the on-device authenticator. And so a bit about the Couchbase stack. I mentioned it briefly before. We have Couchbase Lite, the embedded NoSQL library for storing data on the device and syncing it to the cloud. Sync Gateway, which is the outward-facing cloud component that Couchbase line is going to be communicating with in order to sync all of its data and receive, well, sync, I guess, I mean send and receive all of its data. And then there's Couchbase Server, the internal cloud component that stores data persistently. And some features of it, Couchbase Lite, local data storage and sync solution. It's a document database, so you don't have to have any schema. You just sort of decide what your data means. It's up to you to interpret it, but there's no enforced schema. For example, this key has to be there, or this has to be this type, stuff like that. And there's sync functionality for pushing and pulling data to and from the cloud and directly to other devices if you wish. And automatic retry in the event of a transient network failure. Sync gateway is then receives data between devices and keeps it persistent actually in the cloud and back in Couchbase Server. It's horizontally scalable by a load balancer. You can have independent governance of data read and write access inside of a sync function that you write. And you can inspect its contents via HTTP REST API. And then there's Couchbase Server Ultra CFO, durable cloud data storage solution. Auto balancing cluster with failover, meaning that if one of your nodes goes down, no big deal. They'll reshuffle the data around, not literally shuffle it, but they will tell each other, hey, this guy's not doing his job, so we need to pull the weight. No single point of failure at a moment's notice, any node, well, not any node, according to an algorithm, node can take over for another node if he suddenly goes down, which helps with the above auto balancing. And there's even a SQL-based query language and analytics engine that you can use so that you don't need to be scared coming from relational databases over to NoSQL. You can bring your SQL knowledge with you and it'll be useful. So here's a diagram I made. Look at this diagram. Beautiful, right? Of how things work in FIDO land. Here's how the architecture is set up. I have server here running. This is all divided into remote, which is all up on the cloud.
Is that the right web server?
Yes. Although I have this one running locally and this one actually. I have both of these running locally for my demo, but in practice, they'd also be up in wherever you're hosting things. There's your machine down, and they're communicating by HTTP. This FIDO server is storing things back in the backend in the user's bucket. The sync gateway is storing things to the data bucket, and it's managing the session creation on here so that you can actually be authenticated. And then down here, you have a CTAP that I mentioned before, communicating with the authenticator. And the flow looks like this. First, your machine says to sync gateway, I would like to replicate. And the sync gateway says, nope, you can't replicate. Sorry, you're not authenticated. Don't misbehave. All right, so I'll go to the FIDO2 server and ask it for an assertion request. An assertion is FIDO language for basically a challenge that it's going to issue you. So the FIDO server will go to the server and look up the existing credential that matches the user that's requesting the assertion and send that challenge back to the local machine. The local machine will forward it over to the authenticator. The authenticator will verify and sign it and return the assertion response, which will include additional data on it that's used to determine that, yes, in fact, this device has been the one that's signed this request. So the local machine says, okay, I got this response. I'll send it back to FIDO and see if FIDO's happy. Yes, FIDO is happy, so it updates the credential in here and creates the session on sync gateway and sends back the cookie to the local machine, which then starts again from replication request. This time, instead of 401, says, okay, good job. You've got a nice cookie for authentication. You can go ahead and get my prize data. All right, that's the end of my slides.
I have a quick question. If you go one slide, please. So the first request from local machine to sync gateway, right?
Yes, in
That
this
is the result of the redirect from Couch server?
Couchbase server, the question is it a result of a redirect from Couchbase server, the replication request from local machine? Local machine should not be communicating directly with Couchbase server. That's the job of sync gateway. It stands between the local machine and Couchbase server. And it manages storing stuff in the back and making sure it's available for all the other devices. So it's only communicating with sync gateway. And I have Couchbase server exposed so that we can look at it, but in theory, you'd have it not, you wouldn't be able to access it from outside. You don't be able to access it from the internal network.
All right, so in this sync gateway, nothing to do with FIDO.
Sync gateway has nothing to do with FIDO. It's part of the Couchbase stack.
Okay.
What is FIDO? I didn't understand FIDO to server. Is that a piece of special hardware, or is that an API that does something?
The question was, is FIDO to server an actual specialized piece of hardware, or is it just like an API running? And the answer is the latter. It's a framework for, doing what is laid out in the FIDO 2 specification. The algorithm for doing this sort of challenge and response, which is based on public key cryptography. So it's kind of like when you open a TLS request and you sort of go back and forth deciding on what the key is, except for this time, you go back and forth deciding that it's really you or the person who is in possession of this particular key. And you might think it's not secure because you just tap a button and then anyone can use it, but you would be pairing this with another form of security. For example, this key can have a pin on it, and you push it, it'll require the pin as well. So you have to enter the pin. If you enter the pin wrong 4 times, it requires a power cycle before you can try again. And if you enter it wrong 8 times, it requires a factory reset before you can actually use it again. So no brute forcing this.
So it looks like you're updating financials from FIDO 2 to Couchbase in step 10. So in step 1, presumably you have a cookie already. So if the client that doesn't already have a cookie, it probably knows that it needs to skip steps 1, 2, and 1 and 2. But if it does have a cookie that's expired, then presumably that would be sent along to the sync gateway. So the sync gateway would then have to talk to the Couchbase server and get the credential that's stored in the Couchbase server based on the cookie that it received from the client. Is that a step that's just kind of fitted for the brevity between 1 and 2?
That was a long question about how the cookie is actually managed, but I think the confusion here is the cookie is not coming from FIDO. The cookie is coming from sync gateway. It's the session that I'm saying here in step 11 is actually a session inside of sync gateway. So by this time, between steps 9 and 10, we're done with FIDO. FIDO has completed its task and said we're authenticated. And now that we're authenticated, we're going to do some domain-specific stuff. And create the session inside of sync gateway, and then when we create the session, the response from sync gateway is a cookie that says use this cookie. It'll be good for 24 hours. And you'll send that back to the local machine, and the local machine will send that up with step 1. And then when it expires, the whole thing will start over again because you'll get a 401 again.
The cookie is like the password that proves that you are a member of this session. And then the session knows that it's good for 24 hours.
Well, it's just like any other cookie that has an expiration date. And so when you send up the cookie to sync gateway, it'll inspect it to make sure that it hasn't expired. And if it has expired, then, and the cookie's significance is that I have already authenticated myself. I don't need to do it again. Kind of like a poor man's OAuth token. None of this stuff is specific to FIDO. This is all the domain stuff after it. The actual FIDO stuff is between steps 3 and 10. And the rest of the stuff is domain specific to my demo. So let me see if I can go over here. Stop sharing my screen for a minute. And turn on my camera. Cool. So this is what the YubiKey actually looks like. It's a key. I guess you don't know how big my hands are, but here's a AA battery, and here's the key. So it's a little bit smaller than AA battery and very thin. I'm sorry that I forgot your battery from whatever this is. And it's got this button on the front that you tap, and when it's ready to make a signature, this button, this Y part in the middle will actually start flashing green. So if you have more than one device plugged into your machine, you'll know which one is being asked to authenticate. Oh, it's this one? Yeah. All right. Going back to here. Back to the screen section. Let's get out of there. Phew. Okay, go away. Go away. Go away. Oh, stop being pinned. Before I get into that, don't need that anymore. Hide. This is a Couchbase server I have running in Azure because I got good enough at Azure to actually do probably the simplest thing that you can do in it, which is deploy something from the marketplace. So I've done that here, and I'm going to sign in. And I haven't done much to this to set it up. All I've done is create a couple of users in here. User in Couchbase server will allow you to define roles and what certain people can do and what certain people cannot do. But first, I need some buckets. Buckets are the equivalent of a database in Couchbase server land. So I'm going to add 2 of them. Create a user's bucket. I don't need that much memory for it because it's not going to be changing and being stored that much. So I'll give it 256. I don't need any replicas because I only have this one server running. It doesn't even make sense. Add that. And I'll put the rest of the memory into a bucket called dataset. And since I created these users and I deleted the buckets in preparation for this, I have to actually go back to these users and add back in their bucket specific permissions. So this is the user for the data, which Sync Gateway will use. So it needs the read-only admin access and the application access to the dataset bucket. And this is the user's user, which is going to be storing and retrieving the credentials of the users. And so it needs the user's bucket, data read and write access, and access and query to select, insert, and update. So I'll do that. And before I forget, if I don't do this ahead of time, then I can't execute any queries. I need to create a primary index. Oops, I clicked it twice by mistake. Oh, already exists. Oh, very good. Now it's fully queryable. And that's all I need to do now for Couchbase server. It's ready to go. So
basically, you set up database and the provision table of user, right?
I set up so with tables, buckets. Yeah, they're comparable to tables. And I set up a couple of users. One has access to one and one has access to another. There's actually a third user that I logged in as who's the administrator, but that's not relevant here. So I'm going to start Sync Gateway now. Sync Gateway is based on JSON configuration, which looks like this. Most of this is sort of irrelevant to the demo today, but the key thing here is that I have the server, which is this ridiculous looking thing that I don't know how to change, and the bucket is going to connect to, the username, and the password. And one other key thing here is that I set up a predefined user. This is a built-in user to Sync Gateway, which allows anonymous access to the data. But I only gave it access. What this means is that it's by default it's disabled, so I've just changed it to not disabled. And this gives it like predetermined access to a set of channels. The exclamation point channel is a special channel in Sync Gateway, which means basically public. And so I'm going to start with that configuration.
By the way, to change the address, you just need to upgrade to the paid VM.
Can I use it for my free trial?
No, I guess yes, and your free trial is also payable.
Oh, I've got
there that some amount of the money you can.
Yeah, I got 21,000 yen left. Okay, it sounds like a lot of work though to change that. Actually, the other one I couldn't even get past an IP address. So what am I doing now? You'll see now. I'll go back to the browser. This is now running on localhost. It's the Sync Gateway. So actually, I'm going to go Postman. I'm going to put some documents into it. Remember what I set up? The write access by default lets anyone write. So I haven't changed that. And I'm going to put in a document that looks like this. It's got a couple of properties on it, and the default sync function will route this document to whatever channels are in the channel's key. So this will go to the exclamation mark channel. So I'll put that, and the response is good, created. This one, the second one I'm going to put up, looks like this. This is just arbitrary that I put in for fun, but the real important part here is that I put in channels, not exclamation point this time. This is channels BORRDEN.
And what is channels?
Channels is what you have access to on read from the database. So by default, when I set up the GIST, it has read access from the exclamation point channel, and nobody so far has read access from the Borden channel. Why is this being so weird? Okay, there. So if I go back to the browser and I do this REST call, this will show me all the documents in the database, and you can see that one is visible because as an anonymous accessor, I only have the rights to see this one document. Now we'll go over to here, my actual project. You see there's several projects up in here. There's 3 projects, and I don't know how to make this part bigger, so I hope you can see it all right. But top one is called FIDO2net. This is actually something that I wrote. There's no client implementation for interacting with a hardware authenticator other than in JavaScript and in C. So since I'm Mr. P in book, I wrote the C# bindings to bind to the C library so that I can communicate with the authenticator in C# instead of C. And I made it prettier and more, object oriented. Then there's UB client. This is a program that's going to carry out the flow that I described to you before in the diagram of trying to replicate and not being able to get the data that it wants to get. And the third one is UBSync. This uses an actual third-party library that I found of the server-side implementation of FIDO2, which will, check that the response that it got from the challenge is actually correct. I'm glad that existed, because if I did it, I would do it wrong, and everybody's stuff would be insecure for it. So I'll go over briefly how this is going to work. I'll just say what the code is doing. I'm going to create a database, and I'm going to create a replication on it of poll. And then I'm going to start it. This is all like fairly bad practice in Couchbase land, but I'm doing it anyway because it doesn't matter right now. Just sleeping the thread until it's done replicating. And then I'm going to try to get the not visible block, which is the second one that I inserted. And we're going to see that it's going to be null because obviously I don't have the rights to see it. So I'll pause and say, press any key to perform authenticated replication. And this is where I start doing the fun stuff, which is I send this request, this assertion options request to my server, the UBSync server, with my username and my user verification. User verification parameter is sort of inconsequential here. It basically governs whether or not you need to have the additional layer of security that I mentioned before, where if you push the button, you also need to enter a PIN or do something biometric or what have you, something more secure than just pushing a button. And there's 3 modes. There's discouraged, preferred, and required. I just set it to preferred because it didn't really seem to make a difference in a demo of this size. And then I'm going to send it over to the server, and the server is going to process that and send me back the credential create options, which is basically the challenge. And I'm going to put together the client data. This is what I have found written in the spec. So it's set up the way that the spec says it should be set up. And the challenge is what has come from the server. It's usually just a random set of bytes. and the origin is where the server is running. So I hash that challenge, and then look for the public key that it sent me, which was the registered public key from this device. Whenever you create this sort of credential in FIDO, you end up with a public-private key pair. And you store the public key on the server side, and you have the option, which I think is very recommended, to store the private key on the device itself. And if you do that, you can't actually access it anymore. You can only say sign up with this. So even if someone tries to trick you into giving your key or anything, they can't. You literally can't give it to them. That's the interesting part. Otherwise, if you don't use that option, it'll behave like you would expect. It would get encrypted and sent up to the server, and the server would send it back down encrypted when you needed it, and it would use that.
Are you saying the little device stores stuff?
It does store stuff. The YubiKey, as of version 5, is FIDO 2 compliant, which requires the ability to store private keys on it. And I do think that eventually you will run out, because one of the error codes that I found is device full. I don't really know what you're supposed to do at that point. I assume you start deleting them if you can, or resetting it, but that would really suck. So I hope that it has a very large storage. I mean, the private keys are not very big in terms of data. They're big in terms of keys, but not in terms of actual data being stored. And so this is where my library starts coming in. I create a credential, and I set its type. This is just, there's 2 algorithms that it accepts right now. They're ES256, which is an elliptical algorithm, and RS256, which is RSA. And they strongly encourage using the elliptical one, which is very much like everyone's preference right now at this point. I set the user to whatever this has got sent back to me. Everything with options is coming from the server. Then I set up the RP, which is who is asking for this, who has created this challenge. I set the options, and it's going to tell me whether or not it does require resident keys. What I mentioned before is the resident key is the key stored on the device. So you can choose to tell it whether or not to store it, and whether or not to verify the user by actually not entirely sure on the verification process, but I think that is it's not the pin, because the pin is in another call, so it must be something else. Yeah, I won't get into that because it's not, there are still parts of this spec that I do not understand. It's quite eluding to me. And this is a weird one. I have to add all the public keys that I received at the exclude credentials, so that, wait a minute, this is not the right method, but everything up until then was the same. I realized by except instead of a credential, I'm creating an assertion this time with the client data hash and the relying party, setting the options. So this require resident key is not an option this time, because you're not actually creating anything. You're using something you've already created. But user present true means you have to push the button. If you set it to false, you don't have to push the button. But just set it to true. Make them push the button. It's not that hard. And it prevents misuse from like a key that gets left plugged into a machine, because it'll eventually time out and say, like, look, you didn't push the button after 30 seconds. What's wrong with you? I'm giving up. And instead of exclude credential, this is allow credential. So if you get a public key from the server and the private key is not on the device, you have to tell it, I want this public key is allowed to be used, because, you know, it's not on the device. So how does the device know if you want to use it or not? And then I'll probably please press the security button, because at this point I'm going to open the device, and this is the meat of everything. Get assert. So this is where you would enter the PIN number if you have one on the device. So you have to get it from, you'd have to, if you're going to use this as an API, you have to try it with null, get back the error that a PIN is required, prompt the user for the PIN, and then try again with the PIN number. And then I create the response to send back to the server, and this assert array stuff is all coming off of the device. The device is creating this array. These are all signatures. From what I've found so far, they're not signatures. They're assertion responses, including signatures and other things like the client data JSON and all that stuff, just to make sure that what we're getting back is actually was made with what we put into it. So it's like an HMAC, where you sort of hash the data that you get in and say, and sign that and send it back and say, well, look, I did generate it for this data and not any other data. Oh. And then I call back to the server, make assertion. And on the server side, this is going to take that assertion response, analyze it, and if it is indeed a good signature and everything's in order, on the server side, it's going to create the session and send me back the cookie we ended after the make assertion, we're done with FIDO. And after that, my server is like, all right, we're good to go. Create the session on sync gateway and send back the cookie so we can get this. And I've hard coded a lot of stuff on the server side. I'm gonna go into the server side now. But a lot of the stuff that I described in ask for the assertion and send the assertion is stuff that is basically just calls out to a third-party library. So it's not that interesting. The interesting part here is create sync gateway session, and this is where I sort of hard code some stuff. I send over the request to user Borden and put it onto the server, and I give it admin channels to the Borden channel. So it should be able to see the previously not visible thing. So I'm going to stop yammering on about that and actually start it now. First, I'll start the server. Oops. So this is the server that I made. Very brilliant front end, I know. But I kept the registration step separate from the actual client logic because I figured that's how more realistically it would be handled. So you would go onto this page, and probably at this point you might enter a username and password to verify that it's yourself, and then register your key. I skipped the username and password part. But when I push this, then this pops up. This, I can't make a pointer. This pop-up here is actually built into Chrome, and it gets popped up by simply making one JavaScript call, navigator.getCredentials, or in this case, navigator.createCredentials. And so you send it over your credential creation data, and then it's going to see if you can't see it, but my key is flashing now. So I'll tap it. And I might have time to, yeah, I waited too long. And you can see over here that I've stored a public key. It took me ages to figure out how to actually validate this and figure out what it was, but this is 2 parts of an electrical curve key. X and Y, each 32-bit or byte or whatever. It's cool, I'll just say that. And I'll leave that running, but this time I'll switch over to the client. Start that up. So up until this point, what's happened is that I've created the database and I've started the replication from Sync Gateway. And I know I said that it would return a 401, but that was before I changed it, and I thought it would be better to first have it authenticate without any have it pull down the data without any authentication. So it gets the same thing that we saw in the browser from before. It gets that one document. And I asked it for the other document. I asked it to retrieve the not visible document. It's called not visible because that's the name I gave it. And it says, well, it's no, I don't have that data in here. Okay, so the program has asked me to press any key to perform authenticated replication. This is just a pause I put in so I could hammer on in the presentation while it sat here waiting for me. So I'll enter it. It's going to say, please press the security key button. And once again, my key is flashing. I'll tap it. And it'll take a minute for the request to go through. Oh no, I failed. Let me run it again to make sure. Because you know, I ran this 50 times, and 50 times it gave me the correct result. But this time, no. Let me make sure that I've actually done this. Did I actually push the send button here? No, I didn't. That could be the reason. I never actually put the data in. There we go. Now it's there. Okay, let's try again. I really should learn to make notes. Hashing, tap. There we go. Now I get actual data for the not visible. And I did this all without entering a password at all. And yet, I'm safe, thanks to public key cryptography and this new algorithm. Now, if you were to do this in real life, you probably wouldn't do it as simply as I've done it here. My thinking is that you would use this as a way to authenticate yourself against an OAuth server and get an OAuth token. The thing that everybody's using anyway, just without having them log in to the screen with the username and password. You would go to the OAuth, it would pop up the browser window, and instead of saying enter your username and password, it would say push your button on your key. When you do that, you authenticate yourself, it would send you back the token, and everything after that is the same as it would be with the username and password. And I will end the presentation there, and I'll take some questions, but not too many on how FIDO actually works, because half of it's still a black box to me.
I didn't get, so I saw somebody had a thing, maybe it was this, where you push the button, but it was really small, and they used it to log into GitHub.
Yes, there actually is another version of this key, which is really tiny, like this big.
Yeah.
It's called the YubiKey Nano. And I don't know if it has a button on it, but that was probably the version 4. And version 4 supports something else, which is very similar to this. It's called U2F, Universal Second Factor Authentication. And that can only be used as a second factor authentication method. This one, combined with the other strong verification method, can be used as a first factor authentication method. If you set up, for example, on Android, the fingerprint sensor will serve as both the authenticator by using the secure enclave, and also a second form of verification, the biometrics of your fingerprint. So if it's not your fingerprint and it's not the secure enclave signing this thing, then you can't log in. But for the second U2F, it only does the signing, and it doesn't require anything else. So the vendors all jumped on this, they loved it, and I used it. I have actually another YubiKey, a YubiKey 4. And I bought this one because I was so interested in the presentation that I saw last month here at the .NET Meetup, so that I could actually come and show you how it worked. But this one is more advanced than the last one, and it's using the standard that's meant to replace U2F. Combination of U2F and a W3C standard called WebAuthn, which is actually how the browser and the machine and the hardware authenticator interact with each other. It's all governed by this spec called WebAuthn. FIDO 2 involves part of that, but WebAuthn is when you have a browser involved. I could do everything that I showed you without a browser, but that's why I have all this commented code at the top of here. Because originally, I was go away, please. Thank you. Originally, I was creating the credential as well with this set of code. And the method that I started to describe to you, and I said, oops, this is the wrong method. That was for the response for creating the credential. But I thought it would be more impressive to show you how the browser pops up the little animated key thing and how it only needs one call of JavaScript to do it.
Is that a smart card?
It's not a smart card. Nope, it's different from a smart card. It's just basically like on your phone, you have hardware that accelerates encryption and stuff like that. It's basically a variant of that. Makes it very fast for signing and has some space to store some private keys on it.
Okay. But smart cards are used for, I actually don't know smart cards. So I just saw it in Windows once. It was like, it's smart card authenticate.
Smart cards.
I picked up. Oh.
I'm actually not entirely sure what they are either. I think Ken knows what they are because I think he has one for his. Do you have one for Microsoft?
What? Can we see it?
Can we steal it?
Oh, so it's got like a SIM chip in it?
Yeah, so we can wait for the authentication to runtime. What is his name?
I don't remember his name. The guy with no hair.
Brian. So Brian told us that the authentication is interesting the three attributes. What you know, user and password.
Yeah.
And what you have, which is the right authentication by this DVT or by the smart card. And then the final is who you are or what you are. So like the biometrics, fingerprint. Right. So if I'm using the smart card, this is the provide what I have, but it has to be combined with other or at least other one. If I insert my card, if this is authenticated as me, if you grab my card, you can impersonate me, right? And you can do that when I enter in the office. You can just swipe my card to get in,
like a key to the
like a key to the room. But this alone does not let you log into my computer because the computer asks PIN number, which is what you know about. You know, right? Then, if this is smart card reader or the PC has a biometric reader, like the fingerprint reader, in addition to these two, including what you are, then that's very secure. Not YubiKey. YubiKey has the fingerprint reader, right?
I don't think any YubiKey has the fingerprint reader, but in some of the mobile ones, they combine it with their fingerprint sensors. And Windows Hello does the same thing.
Right. Then it improves what you have and who you are, what you are, and what you are.
I see. So this device, the device essentially stores private keys. Is that the device that you have, the FIDO?
The YubiKey 5 is a FIDO 2 device. It stores keys, so it also incorporates the what you know portion of what he said by requiring a PIN.
I see. So, but it's not like I've seen the RSA keys that generate like numbers. Right?
Yes, there's also RSA keys which actually generate numbers, but
this doesn't do that.
This doesn't do that because we want to make things as easy as possible to be secure. The biggest problem today on the web is people make insecure passwords. They use the same password for everything, or they accidentally give out their password in a phishing attack. So the thought of the YubiKey was, why not try to make it so that passwords are obsolete by replacing them with something better? What he said, what you know, who you are, and what you have.
The private key, where is that generated? So it's sort of the FIDO 2 compliant device. Where is that coming from?
It's coming also from the device.
Okay, so they received some request for. So they generate a private public key and then they return the public key along to the caller.
The device will, if you use the resident key mode, then it will generate the public-private pair. It won't give you back the private key. It'll just keep it to itself. It'll send back the public key and whatever else is necessary to make a valid. There's some metadata and stuff like that inside that helps the validation process on the server. That goes back to the server, along with you have to get the challenge first from the server. It's going to sign that challenge with the private key, so that when the server decodes it with the public key, it's going to come back to the same thing that it sent it to begin with. The standard challenge response, just this time encrypted with public-private keys.
Any other question?
All right, cool. Thanks.
All right. All right, now let's take a 5-minute break. So it's 8:20 right now, so we resume for 8:25. And the Wi-Fi, do you need Wi-Fi port? No? Okay. And the restroom outside, the free drink outside, there is just one piece of the pizza. If you want, and the last one piece.
Email is like a fake Finito domain. It's fantastic. So apparently these are highly effective. They are almost up, yeah. Actually, the staff was about to go out and run to the store to get it until one of the senior members was like, "Where are you going? Why would Alex ask for this? And he doesn't have an iPad." So it was like the strangest, yeah, because the whole thing was very. Like, it's like, hey, I mean, key customers and like, yeah, but the Dropbox thing, yeah, like that, the fake email, not even on, that was a good one.
Yeah, this came from the fake Dropbox email with the Dropbox logo in the background and everything.
Did it download a virus though?
No, when you click on the link, you go to the Dropbox, what looks like the Dropbox page, and you enter your password.
So they're phishing. So I guess this isn't a phishing scam. I don't know what type of scam that I've talked about.
It's just like a fraud.
Yeah, like a straight up fraud thing. Yeah, I've seen the
I got tricked.
office.
I'm ashamed.
Did you really?
Yeah, after you logged in, then they did it on purpose. After you logged in, and said this was an experiment by Couchbase, you called it for it.
Oh no.
That was good. Yeah, and they sent out an email letter saying that like the majority of people know for it. I guess it's something in your mind like goes off when you see like, oh, it's from the CEO.
Wow, that's incredible. We should do the same thing because that is a serious. Yeah, it's like you wouldn't even. I guess you wouldn't even think to do it. You're like, it's that urgent.
We were using Dropbox at the time too.
So yeah. For us, they found out that we use Office 365. So they always send emergency like meeting requests. It's so it was the
Be careful about what I click on do. I
was surprised, yeah, because like yeah. Wow. It's embarrassing to get caught.
Yeah.
Yeah.
The things that we fall for sometimes.
No.
Usually things look weird or out of place, which is why I question them, but it just doesn't look like anything out of the ordinary.
It's automation. You don't print image because it's free.
Yeah.
So everybody in the room? All right, let us resume. All right, so Jim, thank you for the great presentation. And on the other hand, I will do something more like the non-security stuff, like the more like IoT. IoT is very secure though, but nothing to do with authentication or authorization. But before even starting, let me just announcing the very cool new feature of the Microsoft Edge. We just announced Edge on Chromium. So Edge has its own Edge HTML engine, but we decided to move into Chromium base, which is kind of open source. Chrome also running on that. So we have that. Sorry.
You guys totally screwed Cordova.
Yeah, so Jim Borden declared that we Microsoft screwed the Cordova because we are changing but this might be the good thing, right? No. Anyways, so we have the insider channel, and we have the dev channel, and the beta channel, and the canary channel. So please go ahead to try to download the new Edge, which is super fast and super stable, even though it's a dev channel. And please help us to stabilize and enhance the functions even better before we do the GA. Thanks for your help. And this is the place you can download, which is the Microsoft Edge Insider. Easy to remember. Microsoft Edge Insider. Repeat after me. All right, so that's the announcement. So today I will talk about Azure IoT Edge 101. So who know Azure IoT Edge in this room? All right, whoever had Azure IoT Hub? Who had Azure IoT? Whoever had IoT? All right, many people have some idea of the IoT. IoT basically the Internet of Things. So anything connecting to the internet considered to be IoT. So technically, my PC could be IoT. If the fridge is connecting to the internet, that could be IoT. Because my TV is the internet TV, it is IoT. Yes? No? It's kind of yes and no, because my TV connected to internet, but it's not connected from the internet. That's a totally different story, right? So my PC can connect into the internet, but we need somebody to manage my PC from the remote. Intune does it? Anyways. All right, so today I will talk about IoT Edge overview. So the goal of this topic or this talk is for you guys to understand, or at least to be able to explain to others or your folks or the colleagues what is IoT Edge means. You don't have to be expert, but at least I want you guys to be able to explain what it is to your friend. And I cannot explain to my wife, but I'm supposed to be good enough to explain to my colleague. All right. So this is the Azure IoT product. So when we talk about IoT, it is the Internet of Things, meaning the device is connected to the internet. For what? To collect in the data, one, or to send in the command to the device to do something, two, right? So for example, if my AC is connected to the internet and IoT, I can get the temperature information from the AC. If the temperature is too high for my cats, then what I want to do, I can manually set in the temperature lower so that my room is cooling down for my cats, right? Or I really want to make it automation, right? If the temperature is too high, I want the AC to be more like stronger to make the temperature down. So that's the basic scenario. To achieve that, we have so many components. So one component is IoT Hub. IoT Hub is something managing the IoT devices. Imagine you have 10 IoT devices. Not so hassle, right? But if you have 1 million devices, 10 million devices, 100 million devices, you really need to have some management system to manage everything. Then we have the functions to trigger something, and event grid to queuing some data, machine learning to implement the AI kind of stuff. So these are the components classified as IoT, the component, which also including the Cosmos DB. Why we don't have SQL Server? All right, so this is IoT products, but today I will talk about this IoT Edge guy. Then, before we start thinking about IoT Edge, if we think about how we do the AI on the cloud side for the IoT, so on your left-hand side, there is the IoT Edge device. So just imagine this is my AC, my air conditioner, which is connected to the internet. Then I can get the data from my AC to cloud gateway, which is IoT hub, because the IoT hub is managing my AC in my room, right? Then once I get the data, what I can do, maybe we can do the data transformation by using the function application and store that in the Cosmos DB. And at the same time, we are using the stream analytics by doing the stream processing, because IoT sensor keeps sending us the data every millisecond. Sometimes for truth, sometimes the temperature number is too high, or I may want to get the highest value in last 1 minute, or average value in last 1 minute, or minimum value, right? It really depends on what I really want to do. So this technology enable me to do whatever I want to do, right? Then to showing the data, we can use the Power BI, and authentication, we can use the Azure AD. If we want to run some of the workflow, we can use the Logic Apps. So this is kind of everything in the cloud side. Looks cool, but what if we need more speed in the edge side? Because every single action has to be taken in the cloud side. So if my AC is more smarter, they can handle everything by themselves, right? They don't even have to talk to the cloud. Imagine my AC have function inside. Imagine my AC has the stream analytics inside. Then my AC doesn't have to communicate to cloud all the time, right? So that's the idea of the Edge AI. So Edge AI, so this big black square box is edge side, meaning my AC. So my AC has telemetry feature, app inside feature, function feature, or even AI feature inside, meaning my AC does not have to talk into the cloud anymore. Why? Because my AC needs the speed to analyze everything. It does not make sense. But let's imagine the autonomous driving, right? It has to be processed everything very quick, because camera see the kid in front of the car. And do you want to take the picture? Do you want the picture sent into the cloud? Wait a second to get the result back. Hey, there's a kid in front of the car. By the time you maybe already hit the kid. Yeah. Right? So this has to be kind of less than 10 millisecond change, right? In those scenarios, we really have to process everything on the edge. Or in another scenario, if you are working for the very PII sensitive company like bank, the bank really do not want to send PII data to the cloud. If I take Alex's picture because he's coming to my store, I don't want to send his picture to the cloud to judging his Alex. I want to do everything on the edge side, because then we can tell the customer, no worries, your picture never goes to the public cloud. Everything stored inside, right? So there are several scenarios why we want to do the processing on the edge side. Now the question is how you can writing that great code, running everything on the edge side, with the scale, with customizable, with extensible, right? That's the question. So that's where the Azure IoT Edge is for your help. So Azure IoT Edge has a 3 components. One is IoT Edge module. 2 is IoT Edge runtime. And lastly, IoT Edge cloud interface. And I will explain one by one. No worries at this moment. All right, so start from IoT Edge module. So this square the square box is a Edge. Edge has an IoT Edge runtime, and I will explain what this is later. But on top of the runtime, there are the modules. The first one is the telemetry module. Second one is the app insight module. The third one is the Azure function module. So this is microservice idea. every function or every feature is packaged as the container, right? Docker container, and push the container on the edge and let the module talking each other to do whatever they want to do. So let's imagine we have the camera container taking the image from the camera. Then we have the stream analytics container, which takes the stream data. Then we have the action container, which is the function container. If these containers can talk to each other on the edge side, most of the work I want to do should be done, right? Then because this is modularized, if I need to update something for the function side, I just swap the module for the function only. I don't have to swap the module for the camera. Nothing to do with the camera, right? So everything packaged at a minimum the microservice and deploy it to the edge. So that's the IoT Edge module. So this part. And what kind of module is already there? AI module is already there. And the blob storage is also there. This is very nice because you want to store the image to the blob, right? And let's say you're already creating some application to store your image to the blob, Azure blob storage. Now, because we have blob storage module for IoT Edge, you don't have to change the code. You only change the connection string. Then, all of a sudden, application or your application in the module believes that the blob module is actually Azure blob, which is not, which is resides in the Azure Edge side, but it looks like Azure blob storage from your module. You know what I mean? So we already providing the blob storage module, and stream analytics is already modularized so that you can use the stream analytics. How many of you know in the stream analytics? And if you know stream analytics, you know how powerful it is, right? Now we can simply provision the stream analytics inside the small device. Doesn't have to be small, but the edge side, right? And of course, you can create your custom module. Otherwise, I do not explain this in this developer meetup, right? This is where they will shine. We can create our own module. Maybe we can create the Couchbase, the FIDO, something super secure module. I don't know. And the monitoring module is also out of box available. You don't have to create anything. All right. Then the second component is the IoT Edge runtime. So module alone cannot do anything because it's just a container, right? Container needs runtime to run. So like the Docker container is just a container image, but you need Docker runtime to run the container on top of the Docker, right? So Azure IoT Edge runtime take care the running the container side. So this is very similar to the Docker application, but slightly different. All right. So what it does is it's installing and manages the workload meaning each module. Then security, and maintain the modules, and export the status to the cloud. Even though my application is doing great on the edge side, as the application, the organizer or the organization, the manager, I really want to know what each device is really doing, right? So anyway, even though they are processing everything on the edge side, at least I want to get the status report, like we are doing great kind of stuff. So that's the IoT Edge runtime is covering, and to communicate with the cloud interface. All right, and finally, IoT Edge cloud interface. By the way, I have another section to explain the detail of each component. So at this moment, I just go through. But the last part is IoT Edge cloud interface. So the cloud interface is a kind of Azure Cloud Portal. So if you go into the Azure Portal, you open the IoT Hub, then you see all the devices of yours, and you can manage everything from there. So what we can do, we can create and configure a workload to be run on a specific type of device. So for example, when you have a million devices, that million device cannot be exactly the same device, right? Maybe 10 of them could be drone, hundreds of them could be AC, another 10,000 of them could be the temperature sensor, right? And you need a different workload for different types. So there is an easy way to manage everything on the cloud interface side. And then send a workload to a set of devices. So let's say you have 10 rows, but you want to install the latest bit for the only 5 of them. You don't want to deploy everything at once. Then you can specify those 5 as a group and just one click to push the package. Then monitor workload running on the device in the field. So for example, in this drone has a alert sign. So this information can be propagated to the cloud side so that we can see from the cloud side. We don't have to go to the field to check device one by one, only if it's working properly anyway, right? All right, so what is IoT Edge? So this slide is for you to remember so that you can explain to your friends. 1, it's manage devices in the cloud. Then workload is modularized as a container and deploy workloads and support many key features such as AI, stream analytics, and the right blob storage. And the IoT Edge runtime managed device and the multi-platform support, meaning the edge device can be Linux, Windows, and we also start supporting the Linux, the 64-bit version, and ARM Windows as well. And we keep adding the new container. So for example, this is a cognitive service on Azure IoT Edge. So we have cognitive service in the cloud, and you want to running some of the cognitive services in the edge. We're creating the container so that you can running the cloud power on the edge side. This is cool. All right, so let me just explain each component a bit more detail because I still have some time. So IoT Edge runtime. IoT Edge runtime have the 2 functions. One is IoT Edge Hub, and another will be IoT Edge Agent, which I will explain later. So IoT Edge Hub works as an IoT Hub local proxy, meaning from other devices, this IoT Edge Hub looks like IoT Hub on the cloud. So if Jim is a device, if I'm the IoT Edge Hub, when you're talking to me, you imagine I'm an IoT Hub on the Azure cloud. So why this is great? Because you don't have to change the programming model. I can install my application to Jim Borden device. Then Jim can talk it to the IoT Hub to the cloud. But if he doesn't have capability to talk into the cloud directly, maybe he does not support HTTP, right? Then he can talk to me by believing I'm an IoT Hub, which is kind of true and not true because I'm a proxy. So it works as a proxy for other devices. So in this image, we have the robot arm. Robot arm usually do not talk into the internet directly, right? Because it doesn't have HTTP component. Then these guys can talk into one of the edge device, which are the IoT Edge Hub. Then this IoT Edge Hub work like the IoT Hub proxy and talk into the IoT Hub in the back end. So it's just a proxy, right? Right, normal web proxy. And it's optimized authentication hub. So this robot arm, each robot arm is its own authentication, like the client ID and client secret. First time when they connected to IoT Hub, because the Edge Hub do not know about authentication, he simply passing the authentication information to IoT Hub so that we can do the authentication. But once it's authenticated, IoT Hub authenticated, then Edge Hub caching the authenticated information. So next time robot arm coming to Edge Hub, this guy do not talk into IoT Hub. So we can save the network traffic. Because once authenticated, we already know who you are, right? And after several hours or minutes, I don't know how many, but it's expired, then only then talking to the IoT Hub again. All right, so next thing is optimize the connection to the cloud. This is interesting. We have 3 robotics arms on this slide. Each one talking to IoT Hub separately, right? Because these 3 is a totally separate device. They don't talk to each other. So these three devices talking to Edge Hub because it's proxy. So let's imagine the first one talking to the Edge Hub, second one talking to the Edge Hub, and third one talking to the Edge Hub. If Edge Hub simply proxying to the IoT Hub, three connections will be made to the IoT Hub, right? But Edge Hub has the capability to aggregate everything under one connection to the IoT Hub. Yet, this IoT Hub can recognize each three as separate. So this is a connection optimization. Why? Because factories do not have high speed, always connected, the super, ultra, the durable internet. No, they don't. That's why we need some mechanism talking to the cloud in a good way. Make sense? Yeah, because imagine, do you have a factory in the middle of the Tokyo? Maybe yes, maybe no. But we may have big factory outside the Tokyo, which may live in the mountain, does not have a great connectivity to the internet, right? So this mechanism is very important. All right, so next one is IoT Edge Hub. What we can do is a modular communication. As I said, if each module, meaning each container, can talk with each other, they can do their job, right? But how they can communicate to each other? So this is exactly the same with the K3s, which is a compact version of the Kubernetes, K8s. So Kubernetes lets the container module talking to each other to make the microservice complete, right? So this guy doing exactly the same. This IoT Edge runtime, IoT Edge Hub, let each module running inside the device to talk to each other. So for example, the first telemetry of the output, then this output can be used as the input of the second one. The second module of the output, then third module can take that output as the input. You know what I mean? So this is a module chain, which supported by Edge runtime. And like this, yeah. And by the way, this is configurable, meaning you can swap the module, you can add in the module, it doesn't matter because the module only believes this configuration, routing configuration. Something coming from somebody as an input one in this format. And who, I don't know, who is that?
That sounds like the actor pattern.
The actor pattern, yeah, exactly. This is kind of actor pattern, the microservice pattern, right? All right. Then we have the IoT Edge agent. T is, where is I? It is responsible for instantiating modules, ensuring that they continue to run and reporting the status of the module back to IoT Hub. All right, so in this screen, I have three modules. Who take care of these three modules, which is IoT Edge runtime of the IoT Edge agent. Agent sees the deployment manifest, knowing which container they have to run. So they take the container image from the Docker Hub or Azure Container Registry, download, instantiate, keep monitoring if the module is running or not. If failed, report and restart, something like that. So the agent is a guy to keep manage everything. Then this guy reporting the status back to IoT Hub. All right. So does it make sense? So what we need on the IoT Edge device side is IoT Edge runtime. That's the must. We have to have the runtime first. Only then we can install in the modules. Otherwise, nothing happens, right? It's like the operating system or the runtime framework. All right, so Edge module. Edge module is a simply container, which is a container image. So IoT Edge module image is exactly the same with the container image. And the container image can be hosted anywhere, as long as IoT Edge agent can reach it too. So usually we are using Azure Container Registry, ACR, or Docker Hub, because it's very easy to connect, right? And IoT Edge module instance is a runnable object because this is an image, but this is the object, the inside the memory kind of stuff. This is an instantiated version of the container image. Then the development. So if you want to develop a module for IoT Edge, Visual Studio or Visual Studio Code has a template. There's so much typo. And we have SDK for C, C++, C#, Java, Node.js, Python. So we are supporting most of the language, multi-platform, multi-language, which is our keyword these days. And IoT Edge dev tools, and we're also providing the testing tool. So even before deploying to the device, as a Visual Studio family, we can debug everything locally. Once everything going okay, we deploy to the device. It's a DevOps story here as well. And DevOps, right? Because it's just another container application. And when do that deployment, we deploy by using the deployment manifest. So everything JSON. I don't know if we can use the YAML, but anyway, it's defined by using some of the configuration metadata, like what the container image we need to have, in which order, right? Order is very important because you want to run AI fast even before take image, right? We need to take image fast, then use the image output to run the AI. Then we have the target condition, and we're also supporting the rollback because if something bad happening, we want to roll back very quick. That's the deployment. All right, so which platform is currently supported? I do not have enough space to write everything here, so I have a link. By the way, I will share this documentation to you guys later after I fix my typo. All right, so if I click that one, come on, Edge, and this is the Japanese. So let me just change it to English, ENUS. All right. So we have several information here, and this page will be updated in real time, no real time, the timely, in a timely manner. So, for example, Tier 1 support, operating system, Raspbian, Ubuntu Server, AMD64 support, ARM32 support. So if you have a device, just check this page to see if it is supported for the IoT Edge or not. This basically means if your device can install the IoT Edge runtime. That's it. And for the Windows, so there's also virtual machine information and the minimum requirement. So check out that page. All right, so it's a demo time finally. I still have 7 minutes to complete. All right, so let's do it. So how many of you have Windows? Most of the people, thank you. So you can use your own Windows computer in front of you, or you can create in the virtual machine to run in the IoT Edge runtime. I strongly recommend using the virtual machine. It does not break your computer, but it is eating the resource anyway, right? So this is a step-by-step information what we want to do. So step 1, we create IoT hub. Step 2, we provision the device. Step 3, we deploy the Edge runtime. Then we create the Azure Container Registry and deploy. And we have very detailed step-by-step information here. So like the first one, we need to create the IoT hub. So open Azure Cloud Shell to create the add extension first for the IoT hub. Then create the resource group named IoT Edge resource. Then create the IoT Edge device. Create the IoT hub. So this is the first part. So creating the IoT hub. You can, of course, using the UI. The reason why we are creating the CLI, this is very easy to copy and paste. UI sometimes changing, right? Maybe every month. So the CLI does not change so much. So this is a safer way to do the step-by-step. Then after that, you register an IoT Edge device hub. So for this demo, I actually already provisioned my IoT hub because it may take a bit of time, like 2-3 minutes. So if I open up the Azure portal, so this is my IoT hub, right? This is my IoT hub. I already have that. Then what I need to do is I need to creating the IoT Edge device. All right, so let me do that by using UI. So go to IoT Hub. And before, we only had the IoT device here. But now we have the IoT Edge menu. Come on. All right, let's make it bigger. So IoT Edge. So before we only had IoT devices. Now we have the IoT Edge. So click IoT Edge. And click the Add IoT Edge device. And device ID. 10. All right, so I'm creating the device. By the way, this is not a real device, as you may know, just a record in the IoT Hub, right? So this is one side of the digital twin. Now I need to make my Windows as an IoT Edge device. How to do that? There is a PowerShell script. So let me run that by using my PowerShell ISE, run as administrator. It is opening in my another window. So let me just move here. All right, so copy this, paste. So basically, this getting the IoT Edge Windows image from the web and just installing. So let me just run this one. And device connection string. So if I go back to my portal, so this is my registered device. I should have string connection string. Copy, paste. And by the way, this Mobi engine is equivalent to the Docker image. This is the production supported the Docker, Docker running, container running the module. You can use the Docker, of course, if you want. And while this is downloading, let me go back to the step-by-step page. All right, so once I'm doing that, when prompted device connection, I need to enter, which I already do. Right, then after the installation complete, I can check the status by get service IoT Edge, because it is run as a daemon or as a service, right? Then I can check the service log if something went wrong. I hope it doesn't. Then IoT Edge command has a list, the option, which listing which modules you already have. And as you look up, this is very small, sorry, but as you look up the result, the Edge agent is up and running. So Edge runtime is actually another container. So I said Edge runtime is mandatory to run all the modules, but Edge runtime itself is also module container. So it's very easy to up and running. Who is running this module, which is a Mobi, which is the kind of Docker container kind of stuff. All right, let's see. So it's already finished. So let me just confirm by running this command. Finger crossed. And it running. And let me check the status. Finger crossed. Nothing yet. Nothing yet. Nothing yet. It may be a bit of take a bit of time. For my experience, 2-3 minutes time for the initial loading, but it will be coming anyway. All right, so that's the end story of the installing the Edge runtime. Then finally, at this moment, I only have the Edge runtime, nothing to do, right? So I need to deploy my module. And how we can deploy my module? There is a nice module which called simulated temperature sensor. So even though my Windows 10 device does not have a temperature sensor, it simulates right temperature sensor. So if I copy this one and go into the marketplace, create resource, and search for simulated temperature sensor. Nice. And I want to import this module to my IoT Hub. So check my subscription. All right, this is mine. And this is my IoT Hub, which I already created, and deploy to a device. And the IoT device name, which I do not remember. So I click find my device. Yay. And create. All right, by doing that, I get the module from the marketplace, not from the container registry, but from the marketplace. And I set to my place. All right, so running, next. I think I have to put something here. If I see the tutorial, there you go, copy. So this is the routing information. The runtime checking this information to understand how each module is talking to each other. But at this time, I only have one module, and the results should be going to the IoT Hub directory, right? So it's meaning route from messages, everything into upstream meaning IoT Hub. So every information directly going to the upstream. And yeah, that's it. So next. So this is my summary. So as you can see, modules have the simulated temperature sensor, and that's the only one module at this moment. If you have multiple modules, there is a listing here. Then, interesting enough, we have Edge Hub and Edge Agent as a system module because these two are also containers. Submit. And it's deploying. So if I looking back to my device, and if I check the status, so these are the current status. So the device is supposed to have Edge Agent, Edge Hub, and simulated temperature or something. And this is specified information from the cloud. This is reported back from the device. The device saying, yes, I have agent, others not yet, right? So this may take a bit of time to complete the running. So if I coming back to my PowerShell, run the IoT Edge list, then now there we have all three modules running, right? And if I come in back to my cloud, if I refresh, is there any refresh button? No. Let me just going back, device detail. Not yet. So it may be coming later. Anyway, so I have three modules installed. Then view the generated data. So if I do the IoT list, I already did, and I see the three modules running. And this is a command which I can see the data which is generated by the runtime. So as you can see, humidity or the pressure. So this information is keep running, generating on the edge side. Then this information already coming to my IoT Hub. And how to see that? There are many ways to see that, but I do not have enough time to explain at this moment. But you can use Power BI to digest in the data, or you can use any other technology to get in the data out to see how it looks like. And one of the way to look at is actually Visual Studio Code. You can use the Visual Studio Code to checking your device if you correctly configure everything. And if I right click and start monitoring device to cloud message, so this is the information coming from my device to the cloud. See? So the temperature, the pressure, humidity, everything coming from the cloud. And the Visual Studio Code extension give you this monitoring capability. Cool, right? Then there is another, the step-by-step, because I don't have enough time today. I do not go through, but there is another very, very reasonable step-by-step, which tells you how you can use the Visual Studio Code and the C# to writing your own code. And this code is very cool because this code actually filtering the temperature coming from the temperature simulated module. So only when the temperature exceeds 25 degrees Celsius, then report to the server. This function doing that. So you can just follow step by step to see how you can write in your own custom module for IoT Edge. Then you are the IoT Edge developer. Cool, right? That's easy, simple. Yes. Alrighty, so that's it for today. And I'm happy to take any question.
The interface between the functions agents that are running on the device, you output to, you send some data to output, and you don't know where that output's going to be. Maybe it's the hub, maybe it's the next agent. But is there a way to deserialize that into something like .NET objects, so that those are kind of passed around without having to do something like a JSON deserialize some blob of text and hope that it comes back the way you expect it to, rather have that enforced by the platform that this outputs a my temperature object, and this inputs in my temperature object.
Yeah, so the question is how to debug the information between the modules, right?
How to turn it into something. Is it specifically just blobs of JSON text, or is it like fully codified .NET objects that can be passed around inside the runtime?
It's just the string basically, so it's a JSON object. And the way how you knowing that is because you are the developer writing both modules, so you have to have all the control for each module. And for this temperature, the module, for example, these are the documentation, what kind of the information they're actually generating. So you can blindly believe in that, and you can take the data input. Basically, it was a JSON object, so you can pass inside by believing you have the temperature module in front of you.
Is it not a use case to have something like where an air conditioner sells their product with all of this already installed, and then you as a power user of sorts want to customize your air conditioner by adding another agent into that? So like it could actually be like maybe you're not the developer that made the existing agents, but you're going to do your own bit of customization. Is that something that's also possible or foreseen?
Yeah, so the question is if you are just a power user, not developer, is it possible to customize everything? I think you at least want to have the coding capability to writing the custom module, or if custom module has the configurable the function inside, you can define everything in the UI to let the module download the metadata to write the logic up, right? Then the data format is already decided by the AC, the company, anyway, so the user don't have to care, right? So you have to know which coming, and you have to define which is outgoing for others to use. So it's like the middleware pipeline for the ASP.NET Core or ASP.NET, right? Each middleware trust each other to believing that this is the data which is coming from this one, and I am the guy to providing this kind of data to others. And I do not know who is receiving the information, because it is the routing the information, right? If I decide to this module, output should go to upstream, it goes to upstream. If I decide this output should go into module B, it should go into the module B. But then module B have to be ready to accept that information input. Otherwise, it doesn't make sense, right? If the camera module should be providing the image file, the basics for encoded string, then the analyzing module have to expect that, right? That's a protocol comes in. But the data between have to be either string or binary could be. I don't know. I didn't go that deep yet.
Is it actually queue-based? The communication queue?
Yeah, communication queue, and the reason why they need to queuing through the runtime. Runtime, because the module do not have to worry about. Module automatically receiving. There is no way to ask somebody to get the data. You don't have to.
I think it's the same as the function queues.
Yep. And if you really want to specify that by yourself, you can use the blob module in the middle to store the data to the blob. The blob module, and from another module, you can take the output from the blob. By the way, that blob information can be automatically synced to the Azure blob automatically in the background, if you specify that in the way.
I noticed that the interface is the same between IoT Hub and the Edge.
Yeah.
But does the Edge, for example, support devices that are dumber, so are less able to handle the security requirements of IoT Like, because you want to talk to IoT Hub, you need a certificate, you need to talk to HTTPS. If you have devices that are not capable of doing that.
So there is the certified devices. So we have the device certification. So if you are wondering if the device really can supporting all the edge function,
No, it doesn't.
yes.
So
And if you know it doesn't, it shouldn't work.
well, then what we need to do is we need to put something in front of it.
So
to
the
handle all the secure communication.
yeah, so that's the another IoT edge device in front of the device. That's the robot arm, the sample,
Yeah,
right?
so the robot arm would be really, really stupid.
Right.
So it needs to talk to something, then upscale the message to actually talk to IoT.
Right, but I am not quite sure if you can be changing the message in between you. That's
Not the message
proxy, right?
itself, it's the
I mean,
security.
the authentication, right?
Yeah.
That I need to check.
The feeling I got from it, I'm not, tell me if this is right, is
Yeah.
that the platform provides the functionality. And so inside your platform of the ARM, which is very stupid, the functionality of report to cloud is actually sending just an unencrypted message to a device in the local network versus the same function inside another device that is smarter and more capable of actually talking to IoT cloud would actually do the packaging and everything else,
So
right?
the problem we've actually got here is the device needs to send about 100 bytes up. But because of the security functionality hub, it turns out to an 8K network, which is blowing our network usage out of the water.
I think that's what, I mean, that's the purpose of that. Is
Yeah.
so that for the dumb devices, I assume you have like a proxy function of some sort
Not yet.
that would be part of it.
Yeah, so we can double check that. If you have the specific device you're talking about, we can do the hackathon.
I guess I'm still struggling to understand the actual use, like a real use case, because like we've got an IoT device, which you said, an air conditioner, a refrigerator, a robot arm, running a full computer server with Docker, with all these containers. Isn't it just easier to write simple code that just does like what's the use like?
If the writing code is simple enough for you, go ahead to do that. But if you want to be using that module to be everywhere with everybody,
but I mean, what device? Because like I'm thinking, I don't know what app insights a refrigerator needs, or like so. What is a
so let's imagine my fridge wants to know which the food inside my fridge. They want to take picture. They want to send they need to send a picture to my crowd to identify 2 apples, 3 bananas, right? But if I don't want my fridge to send my picture all the time to the crowd. If they can do that local, right?
Do these exist? Like,
So we've got one actually. So we've got devices that send a message once an hour over the standard phone network. And in the future, we're going to have Bluetooth devices that send a message once a second.
What does it do? Like,
temperature and location.
Okay, for like,
You put it in produce, and it goes on lowering.
Right. And if you don't mind sending everything every time to the crowd, that's totally fine.
So in this case, the device is doing it once an hour, and like there's only like 4 messages there. But now we're going to switch to Bluetooth. Bluetooth will send a message once a second. You don't want that volume to go up to the server. You want something in between that will just send the unique messages that will send the bit you're interested in.
Okay.
Right. So you can get to the aggregated information. So there are the many the one the performance, another is the security or the privacy.
Oh, okay. No, but the bigger thing is it's temperature data for trucks. Oh, that's what that was. I just don't know much about Internet of Things other than like I just see people posting things of devices that never work.
Yeah.
Refrigerators, like air conditioners.
They're very simple.
But the reason why it doesn't work very well is because it's not intelligent. Then they have to use the cloud power backend, but they cannot really do it. Then this may help, right? It really depends. If we enable giving the very super high power AI module by using this one, and maybe a C company employing the IoT Edge, IoT Edge, then all of a sudden that AC can be smart thanks to enable, right?
We actually have to deal with IoT a lot of Couchbase as well. So
we
have one use case from Emirates where they will populate their devices with data while they're on the ground, and they'll take those devices. We have a use case from
one of our customers at Couchbase where they will take devices and they will sync data from their server on.
So what device?
Like a tablet.
Oh, okay.
And they'll take a tablet and they'll populate it with their data, pre-flight data. They'll take those tablets onto the flight where there's no external internet. And those devices will all need to be connected somehow and communicate with each other and exchange data with each other locally while they're in the air. And then once they're back on the ground, all that has to be aggregated and pushed back up to them.
Is that Internet of Things?
That's part of the Internet of Things. You got to connect together devices that are talking to each other without going through an external network of any kind.
I have one question. So what?
But please hold. I need to explain a bit. Sorry. So the Internet of Things that was very tricky.
Yeah.
Right.
I thought it was just refrigerators and air conditioners.
So anything
Anything
is connected to the Internet is the Internet of Things. Right? We did a thing for the Internet. Then the question is how we can utilize that capability. What if your TV is connected to the Internet? What if your cat is connected to the Internet? What if your dog is connected to the Internet? What we can do, but what we already have is totally different in the story, right? Then so far, many IoT devices already taking the data or accepting the command. It's like the remote controller. I can do change the channel, TV channel from my office. What's the point? I don't know, but anyway, I can do that because it's IoT. Yay, right?
Yeah. That's my image.
But if the TV is smart enough, right? If the kid is sitting in front of the TV, if there is a vibrant scene in the front of if all of a sudden TV can change the channel by themselves, it could be smarter, right? But how we can do that? Maybe we can doing that locally without talking anywhere. How to update that, right? And how to manage everything, right? Of course, many things can be on local, but it may be good with cloud, good with the internet. That's a choice. I don't say everybody should do this. This is the choice.
I see. Yeah. Okay, so now that I'm picturing like a Nest thermostat with all this. So it's not necessarily for a use case like that. It's for
I understand. 1,000 sensors in various locations recording temperatures. And if you see a problem, like too high, you want to send an alert. Well, you don't have to send that to the cloud. You press a server in the warehouse. The thing is, 50 miles down the road, you've got another warehouse that's another 1,000 devices.
I just didn't know that was called Internet of Things.
Okay.
I thought Internet of Things was a temperature sensor that's connected to the internet.
It could be temperature, it could be humidity, location,
anything.
Okay.
And it's really depending on the business.
So it sounds like it's just a very big word that
big word. It's like big data, cloud.
It is a pretty total buzzword.
Yeah.
Okay.
It's really rapid. What is lab?
I feel like it does have that kind of it feels like
this
smart thermostats to industrial setting.
Or like the smart light bulbs that have Wi-Fi. They call that Internet of Thing light bulbs. And I thought, it's just anything with a Wi-Fi chip, but it's a much broader use case in the context you're talking about. I see. Okay.
You can imagine like this building having Internet of Things light bulbs and being like, okay, we need to know when our light bulbs goes out so we can notify operations to come up, facilities to come up and take care of it or something like that.
So if we simply turn down the right, we can do without any connecting the internet. But if we want to monitor everything, if we want to take utilization of the power, then we want to get the allowed status right?
Well, I was talking about the light bulbs that have individually addressable IP addresses.
Could be if not, we can be
necessarily
because we have the edge.
Participating
Okay.
By using some smarter device to talking to the on behalf.
Those Wi-Fi bulbs go right through your router to their website.
But if the light bulb already talking to the Bluetooth, if the Bluetooth device can talking to the internet, then you can bypassing the device. That's another story.
Okay, now it's making a lot more sense. Okay, thank you. Sorry.
Right, your question.
Yes. So my question was, what was the minimum hardware requirement?
So the question is, what is the minimum hardware requirement? If you do nothing, very minimum. If you do very heavy workload, the minimum requirement could be higher. It really depends on what is your workload.
So the thing is, if everything is well architected in runtime and layer stuff. So for me, it requires, I don't know, PC as 10 years ago something.
Raspberry Pi should be okay. But it really depends on what you want to do with this module, right? Because if it's the very hard and the AI kind of stuff to analyze everything, which also require the bigger storage, the requirement could be bigger, right?
I think the minimum requirement is an operating system.
Yeah,
That's
the reason.
Like
That's
Arduino will work
way.
because it doesn't
At
have
least.
OS.
At least. But how many memory you need to have, it really depends on each
Yeah, use
module.
case.
And usually our module giving you the minimum requirement. If you're having the first module, this is the minimum requirement. If you're using the Lewis module, this is the minimum requirement. By the way, Lewis also can be running on the edge. Language understanding. You don't have to send all the text to the cloud to identify what they want to do.
Where does Windows embedded fit into, like?
Anywhere they want to, anywhere who want to embed Windows.
No, the window, like Windows CE, Windows XP embedded, like the Windows embedded operating system.
We have Windows IoT Edge. We have IoT. Windows 10 IoT.
Is the only one now. The rest of them are.
That's the operating system there, Windows 10 IoT.
Yeah. It's renamed to Windows IoT. Yeah. That's what Windows IoT is. It's Windows embedded.
Yeah. Slightly different. Windows IoT is more like the IoT focus. And on the other hand, Windows embedded could be like the embedded version, or like the current navigation system should be Windows embedded rather than Windows IoT. Windows IoT
Is basically headless.
Yeah.
You control it from another machine.
Yeah, I know the older
ones are like.
I mean, IoT devices can be very stupid and very clever.
Okay, yeah.
But with this one, it could be smarter. So, right, so it's really how to categorize. The best way is if you have a scenario, let me know, so that I can give you the answer. This is something you want to do.
Yeah, now I understand. It's not just a single light bulb.
Yeah.
This isn't designed for the light bulb with the Wi-Fi chip in it that connects to their website. This would be for a much larger application.
Much larger application. So it could be much larger, could be very simple. It doesn't matter, right?
Yeah.
But the key part is we are using the industry standard technology, like the Docker container. That's not the Docker, sorry, the container. And so we can reuse the container by installing the SDK so that the container has to understand its runtime anyway, right? But that's the way requirement. So the function can be run local, right? And if you consolidate everything into one module, then it's going back to the monolithic world. You want to go into the microservice world, depends on the context. But this IoT can do that.
Is there any relationship between Microsoft Edge and IoT Edge?
So Microsoft Edge and IoT Edge nothing to do. Microsoft Edge is a brother name.
Yeah. No, just you chose the same name. Like
Yeah.
Microsoft
Because the Microsoft
So like,
Edge,
why would you choose the same
Microsoft Edge meaning the edge of the technology of the web browser. Cutting edge stuff, and the IoT Edge is simply the edge device.
If you came out with a phone and called it, this is Microsoft Azure.
Yeah.
Like, hey, yeah, I get it's different.
Right. Yeah.
At first, I was like, oh, it's somehow.
Right, let's bring me the good things or how we identify which edge they're using. Also, let's say you are running the web application, web server, how to define the Chrome has the Chrome name in the header, right? So edge header of the EDGE as the edge to identify, and the Chrome base, the Chromium base edge has the EDG or EGE, something like that. one letter little, which is not typo, which is trying to be unique to specify this is new edge. Better than more the letters, right? Best letter is good for the internet, the speed.
Edge plus plus.
Edge plus plus. Anyway, sorry, we extended the time long time ago. So for the YouTubers, not YouTubers is us, right? YouTubees, I don't know. All right, YouTube audience. All right, goodbye.